just wanted to go through another example of simultaneous equations, even though we've covered a few examples, and there's plenty of examples in the book, just to go over it again, because it's one of the, maybe one of the more tricky things that we do. So remember, whenever we're asked to solve sort of a system like this, we usually, or we inevitably will have one of three cases happen. The case that we're usually hoping for is to have a single solution. So this happens when we have two straight lines, they intersect at a point, and this point gives us our x, y coordinates that solves the system. So the point at which they intersect is exactly our value for x and our value for y, which satisfies both equations. We can also have the situation where we have no solutions. So this corresponds with the parallel lines, something like this. Now this happens when we have this first equation may be repeated, but the second side is different. So parallel lines, often it can be reduced to this. Of course, this equation could also look like this. So in a little bit of disguise. So these two equations also would be representative of parallel lines, because when we reduce it, we end up just having maybe a different constant on this side. And there'll be no solutions here. So it basically means there's no value that x and y can take that will satisfy both of the equations. And the third possibility is to have an infinite number of solutions, and this is when the lines are exactly the same. So I have one line, and then this other one is exactly on top. And this happens when you have something like this. So I have our equation, and then maybe this, and we can see that this second equation is exactly the first equation, but just everything's multiplied by 2. So it represents the same information. We don't always know, looking at it, which of the cases that we're going to get. Now, in this situation, we can see that it's not in the general form that I usually start with to solve my simultaneous equations. So the way that we've usually been looking at them is we have, something x plus something y equals some constant here, like this. And it's usually from that starting point that we use to solve them. So maybe I want to rearrange these so that I get it in that sort of form. So this one's okay. Or maybe I'll make it so that the y and the x are around the other way. So negative x plus 4y equals 2. So I haven't done anything there, just changed the x out here, remembering that it's a negative x, so it's negative x, and remembering that this is positive y. So I haven't done anything, I haven't multiplied the equation, I've just moved it around a little bit. For this equation here, maybe work with it a little bit. I want to get the constant over to this side, and I want to get y over to this side. So I'm going to have 3x minus 7 equals y. I'm going to add 7 to both sides, so to make it 3x equals y plus 7. And then I'll subtract y from both sides. So I get 3x minus y equals 7. And now this is the format that I want to work with. So I have this as one equation, and then as my second equation I'll have this one here. So let's put them together. So I've got I have 3x minus y equals 7, and then I've also got negative x plus 4y equals 2. Okay, so the first step in solving this equation is to multiply one of the equations by a number so that two of the coefficients are the same. So I either want them both to have a 3x or a negative 3x, and I want them both to have a 4y or a negative 4y. Now we can do two things. So say I want to eliminate x, then the logical thing maybe would be to multiply this equation by 3 or by negative 3. If I multiply it by 3, then I'll have negative 3x plus 12y equals 6. Okay. If I multiplied it by negative 3, then I would have positive 3x minus 12y equals negative 6. So it's exactly the same whether I do it by positive or negative 3, just all of the negatives or positives change around. And then it just depends how I want to deal with the next step. So let's for the moment just multiply it by 3. So I'm going to have negative 3x plus 12y equals 6. I might label my equations so that I can keep track of them. So I'm going to call this my equation 1 and this my equation 2. And now I've multiplied 2 by 3, so I did 2 by 3. And so I'll call this equation 3. And now, in order to eliminate the x, I actually just add these together. Because this is a negative and because this is a positive, adding them together will cancel out x. If this were a positive, then I would subtract them. But adding them together, so I'm going to have equation 1 plus equation 3, like this. And so what I get here then becomes 3x minus 3x, or 3x plus negative 3x gives me 0, so the x is cancelled. Put the 0 in there. And then I've got negative y plus 12y, so that gives me 11y equals 7 plus 6 gives me 13. And now I can solve this equation because it's now just y in terms, I've got a single variable, and I can solve that by dividing through by 11. So let's move up a little bit. So now I've got 11y equals 13. I'm going to divide both sides by 11. So I get y equals 13 on 11. And now to find my x value, I can just substitute this into any of my original equations. So perhaps I'll use this equation here. So I'm going to have 3x minus 13 on 11 equals 7. So I add 13 elevenths to both sides, and I'll get 3x equals 7 plus 13 on 11. Might need to change these into the same form, so I'm going to have it as 77 on 11 plus 13 on 11, which gives me 90 on 11. So I've got 3x equals 90 on 11. And as my last step, I can divide both sides by 3 or multiply both sides by a third. Since I'm dealing with fractions, I might think of it that way. So multiply both sides by a third. And then I'll get x equals 90 on 33, or 30 on 11. Okay, so this is my x, and this is my y. Two fractions here, not nice whole numbers, but that doesn't matter. We still do everything in the same way, just dealing with different fractions, etc. Of course, at different steps, I could have instead, with my original system of equations, I could have multiplied this top one by 4, and then eliminated the y's. I could have used negative 4, could have multiplied this top one by a third. Lots of different possibilities. Usually just do the one that occurs to do first. As long as we get the result of having either the x or the y with the same number as the coefficient, then we can cancel and continue to solve the rest of the equation. Okay?